that is coming down the pike in Python 3.10, which is still in rapid development, but this feature has gone through all the PEP phases. It's been approved by the steering committee, and so they're kind of slating it for inclusion in Python 3.10. It's called pattern matching. And so I'll be talking about what pattern matching is, why you may like it, or why you may need it rather, how it's used, and then kind of touch on when it may not be useful, and talking about some of the limitations that Python, being a very mature, very kind of stable language, Python 3 transition aside, where that's beneficial, but also detrimental to potentially novel programming concepts to catch on elsewhere. So, so we've got a problem, right? I've got some data coming from a pipeline, and here's like how one may invoke a data class. For example, I've got a person with an ID and a name and an age. What if so now I've got this data coming in, I want to do something on it. So I've got this handler function. So I want to do some action on the data if it's a person under the age of 13. I'm storing user data. I can have children's user data in my system, so I'm going to shut them off to like Disney.com or something. What you see here is I have to first check to see if the data class, in this case, the one essentially in the previous slide, was a person, and their age is under 13. This is fine. We're all kind of used to this syntax as Pythonistas. This is run-of-the-mill Python. The problem is, okay, well now let's complicate our data model, because data is never simple. I'm going to not only have my usual fields, but I'm going to start tracking, okay, well, is there a phone operating system? Oh, and what kind of car do they drive? Okay, so I'm going to have another data class called vehicle that has some other attributes with it. All right, so what does that look like when we bring it into our system? All right, so now I'm going to switch on age under 13. And otherwise, if they're not meeting any of those criteria in that conditional statement, I'm also then say, okay, are they a person still? Cool, what's their mobile OS? What's their vehicle make? Oh, and well, if they're a subscriber, they do different actions. And you can kind of see this, this mess of rules. So there's some things here that are more around the shape of the data, like is this a person or a subscriber? Do they have a vehicle or not? And some related to the actual state of the data. So what's their vehicle make? What is their age? And as you get this formed, these rules become almost immutable. You better hope you have really good unit tests written, because going back 6 months after writing a large chain of these to make any changes is an exercise in patience. Similarly, okay, well, JSON is the lingua franca of the web. We deal with JSON every day. Here's how one might model that data class as a JSON object. Similar kind of thing. Instead of classes, I have to have some like type information decorating my actual JSON object. What does that look like? Okay, well, now we're dealing with the fact that JSON just maps to a Python dictionary, right? Obviously, you can use some helpers around data classes to get JSON to a data class, but let's pretend we don't have those or haven't written those. So now I have to check, okay, is this of a type? Oh, and now I have to do this weird, not necessarily weird, but I have to do this very painful ceremony around trying to look up nested dictionary items. And so this is one way one might do it. There are libraries that let you look up things by JSON path if you want to pull in a library, but this is all vanilla Python, and that's kind of what my target is, and just to keep my dependencies simple. So, all right, so now I have to do defaults for getting data. If data is there, it's going to be empty dict, so I can still do get on it, so there's no none type errors. And once again, talking about things that might be unmaintainable, this is quickly kind of descending into that territory. So yeah, so let's take a step back. The good news about programming is everyone's got an opinion, and there's a different programming language for every opinion, pretty much. I definitely don't want to start a language war, because every language brings something to the table. Otherwise, Sun wouldn't have spent time working and like putting blood, sweat, and tears into a language. So I've, in my past few years, been like delving into some of the other languages that I think offer some really interesting concepts. And one thing you see a lot in two of the languages that I've really enjoyed using, both Elixir and Rust, are, and this is not unique to them, these have come from programming languages that predated them. And like, it's a very functional programming-ish concept, so I can put that on the table right now so Vic doesn't chime in. We have a thing called a pattern matching statement, or pattern matching is just a general concept, but they're expressed through these statements. So in Elixir, for example, you'll see this case statement where I can say, given this like list of 4, 5, and 6, if it is just consists of the elements 4 and 5, then return the value 1, or the string value 1. If it's 4, 5, and something in the third position, return the value 2 interpolated with the value in that third position. So in this case, the x would be 6. And if none of those match, then just default return 3. In Rust, you could have a similar kind of concept where if I've got a number of items and I want to offer a pretty printed English version of that, I could say match on my value, which is in this case x. If it's 0, 1, then return string not many. Otherwise, if it's 2 through 9 inclusive, then return a few. And if it's anything else, just say lots. So this is a really ergonomic way of expressing things around the structure and like state of the data. So if you look in this first example, I'm saying this is a list. If it's a list of 2 elements with 4 in the first position and 5 in the second position, that is like a really succinct way of expressing something that you saw on the previous slide was lots and lots of lines of Python. So let's get into what Python is offering. So going back to what we had earlier, where we had this on this JSON object, I guess, yeah, so mea culpa, I include the JSON, but we've also got the data class here. So pretend this is the data class snippet up top. Instead, the second code block is actually what the Python would look like. So I'm saying if my data is a payload item, and if it is a person data class with the age field being an integer, take the value age and make sure it's under 13 and then do something. That's called a guard expression. So I kind of want to highlight this match statement because some of you who've maybe around with Python for a while may notice that, hey, that's a keyword. Why are we introducing a keyword? I've got match in all of my regex code that I've written years ago. Is that going to suddenly break like it did when we introduced the async keyword? I have good news for you. It's not. And one of the reasons Python's development has kind of been in this jerky kind of back and forth ebb and flow of new features and then some releases that are good improvements, but perhaps not exciting, is because Python is a very old language. It's got some history and some legacy, and some of that legacy holds us back. And so it takes a lot of effort from a lot of hardworking, underpaid or unpaid people, volunteers, to move the language forward. And so I'm going to touch on the new parser that came in Python 3.9 that makes this all available. So I'm not trying to dive deep into CS fundamentals. Everyone's got a different background. Totally understand that. I'm hoping to throw enough words here that if something sounds interesting to you, you can just Google it. Because there are plenty of people who are far smarter than I, who've written far more eloquently or spoken far more eloquently about these concepts than I have. So I'm not going to do them a disservice. Python with 3.8 and below used to use what was called an LL1 parser. And that basically means when it's trying to read the source code, it only used to look at the next word. So if I write the word if, it's assuming, okay, well, the next word has to be something like an expression. So not X or X, etc. And that was fine. It worked, but it kind of held the language back. So in this case, if we had the word, if it encountered match, Python 3.8 would assume it was a variable because we have no, we assume it's a name that could be associated with a variable or a function, for example. So if the Python Foundation wanted to turn this into a keyword, that means we could take the variable name out of the language. So that means you can't name anything match. If I want to say match equals 1, that would be in this new version of Python with the old parser, that would be a syntax error. Just like right now, if you try to type async equals 1, that would be a syntax error. This happened with async and broke code that used async as a name. There was some drama around that, but there was enough Python 3 drama at the time that was kind of one of the lesser dramatic items, surprisingly. They kind of people had a bad taste in their mouth for that. So in Python 3.9, they spent a lot of effort introducing a new parser. Guido and his team definitely steered this forward. So what that means is when it's trying to read your source code, Python can now try different parsing options. Moving on to the next one, when one of those options fails. If it's kind of like a depth first search for parsing to kind of pull it back into some CS terms. So in this case, if I encounter the token match, Python 3.10 can first continue parsing as if it's the start of a match statement. And if it is, then it will treat it like the keyword. Otherwise, if, for example, I encounter a token that indicates, oh, actually, this is not valid Python code, it can backtrack all the way up to that part and say, actually, no, it's a variable name. And so with this, it's now possible to introduce new keywords that are backwards compatible, because this way you're not introducing new sigils, new symbols, things that are foreign to people. So it's a really good way of moving the language forward, and it was a very necessary piece of infrastructure work that no one noticed, but has unlocked these really unique cases going forward. Actually, I do have a quick demo of what that might look like. So right here, I've got a Python 3.10 shell running. So what I can do is show, okay, well, I'm going to type match. Well, it doesn't have the name match. So I'm going to assign, actually, I'm going to match equals foo. Cool, right? So match is foo. But I can also type match case. I'm going to just fall through. That means, actually, I'll do case bar dot bar. Otherwise, case underscore, and I'm going to do like print match. That's a lot of matches. So what I'm saying is, look at the variable match using the keyword match, so to speak. If the value of the variable match is the string bar, then print got bar. Otherwise, this is like a default block in like a switch expression or something similar. Just print the value of it, and I get foo. Another thing I could do, for example, is if I wanted to instead capture, I could do something like case X. I could do print X, and you get a similar kind of outcome. But showing so what we have here is a notion of a capture, where a variable in this case has a different behavior than in your normal code. Instead of accessing the value of X, it's saying store the value of match in X. And that's where you get into some of the patterns I showed in the Elixir example. It was like this item in this position could do that. So kind of going on to that, what I have here is some code that would kind of demonstrate this message handler. I'm going to go through, and this will print. This will do two things. It'll first operate on data classes. So it'll say, I'm just doing these checks that I showed you in the earlier slides with these if statements where I check shape of data and state of data, similar with JSON. And I also have a file that's just got all these data items. So I've got a feed of data classes. I've got a feed of JSON classes, and these will just be walking through those. So let's see what the Python 3.9 example gets us. So what we'll see is it'll just go through, it'll do some it'll execute some rules on those, and both function identically in Python 3.9 on JSON data and that. What's important to note is just the increased verbosity of these checks. This is going back to what I said about maintainable code. That is one of those things. I've got here a Python 3.10 example. And if I want to class these side by side, like I've got a 4-line if block versus a very succinct 1-line case statement. And so yeah, this is matching on, and ignore the syntax errors. I don't have a linter that's Python 3.10 compatible. Oopsies. So yeah, similar case here. I've got a person object. I'm matching on them if their age is under 13. I can match on a person with a mobile of iOS, but then I only capture the version of make, so then I can do something on that, or I can capture variable. It's kind of mixing all these concepts together. I'm going to put these up on GitHub for people to peruse later on. Just want to show like the different patterns that one may be able to execute here in this pattern matching talk. Did not intend for that to happen, but here we are. To run that similarly, and similar kind of pattern. So the same input data and the same outputs, but with fewer lines of code, and to me, more maintainable code. Generally also falls in line with fewer lines of code. So yeah, there are some shortcomings. Python, sorry, Jim, were you raising your hand?
Yeah, so what ended up being the total line difference between those two files?
So obviously, you could technically combine these. 60 lines to 40 lines. Thanks. And that's just for like 3 checks per data item. Yeah, so shortcomings. Like I said, Python's kind of Python has made some trade-offs, and some of them are like have helped the language grow as popular and as powerful as it is today. One of the big trade-offs to me is non-exhaustive. Not exhaustive rather. So other languages that maybe have a compile step or a more baked in notion of typing will know if you're actually catching all possible cases of a pattern. And if you aren't, they can like yell at you and say, hey, you've got an error in your code here. This is especially important for functional languages that introduce the concept of sum types, for example, where you want to execute based on a potential value of an enum, essentially. And if that value isn't met, then you still need to have output. And so they force you to address all your state and your data ahead of time, so you don't get a runtime error. Python doesn't have that. I don't know if once pattern matching lands, if some really enterprising linters will be able to kind of really parse the ST and understand things. I have a feeling it'll be more playing catch up and introducing rules and like practices around how one may use it, but that's kind of one challenge. The other thing which really kind of bums me out, which I totally understand, is that it doesn't return anything. Other languages let you form these really nice pipelines, and you can actually return a value from you can assign a value from this pattern into a variable. Python kind of dipped their toe in the water with the walrus operator in Python 3.8, where you could assign to a variable and execute like the same inline like that. Unfortunately, that has not necessarily made it into this initial version. It was something they initially proposed, but they couldn't really get a good syntax on it, so it might have been punted. So it made it maybe possible, but to do something like this in this code block, I would love that, where I could say, I want to have a point class from this user input. If it has 2 elements, I want to create a point with that zeroes out the z coordinate. If it has 3 elements, then I just want to create a point with those. And actually, if there's empty for some reason, I'm just going to pretend that it's like a junk 2-dimensional point. That's probably a typo on my part, so pretend that there's a 3rd 0 in there. But to have that in a single like statement to me is like really attractive. I understand why people may have gone with it. It's a lot of confusing syntax all at once, but it's something I miss. And I kind of, as has been alluded to, this has been received in a very kind of, it's not been the best reception. It's obviously new syntax, which is always challenging. Like Python is it's one of those languages that's very beginner friendly, but also it's like the batteries included and just the speed of implementation make it attractive to people across all parts of that expertise spectrum. So there's that, but there's also some new behaviors. I saw some eyebrows kind of furrow in chat when I introduced this concept of what we've got here, where I've got this person, age, and age. That looks like a constructor to people, but it's actually not constructing anything. It's just describing the shape of data. So there's a bit of a muddying of the water of what certain syntaxes mean that could make it a slightly more unapproachable language construct for the people just getting started with Python. And additionally, yeah, people are like, well, I have if blocks, they accomplish the same thing. Like the async keyword, that did something drastically different. Like this whole notion of coroutines, et cetera. Like that's a whole, like, that's just the tip of an iceberg. Whereas here, it's like, I'm just writing a cooler statement. And as I said, I'm sympathetic to some of these concerns that people have offered, but I definitely do think there's some benefit to the syntactical advantages that this provides. And I will say it's definitely better received to that end than the walrus operator was. I think because people just looking at, for example, line of code difference, like being able to take 60 lines to 40 lines is better than, is a more attractive proposition than taking 2 lines to 1 line. So there's a bit of that as well. But yeah, that's a quick crash course in pattern matching. Once again, I encourage people to, this talk will be up, I encourage people to deep dive on whatever parts of this were interesting to them. Plenty of resources out there, and play around with different programming languages. It's a great way to kind of learn new concepts and bring them with you back to Python. Okay.
Cool. Thanks, Aru. We'll open up for a little bit of Q&A, like 5 minutes of Q&A. Anyone got any questions? Feel free to ask. No questions on pattern matching? All right.
He made it look way easier than I expected it to be. So I don't know if that's, the skill of the demo, and when I go to roll my own, I'll run into some pitfalls.
Demo data is always the best data you're going to encounter. So
cool. Then I'm going to stop recording number 2 right